So today we are going to see about circular queue, which is going to be implemented using array implementation. So previously we have seen enough examples how queue is implemented using array implementation and using linked list implementation. So today we are going to see about circular queue, which is implemented using array implementation. So circular queue. So what is the difference between a circular queue and the normal queue? So when a queue is implemented using array implementation, so I have a queue of size 5 and 5 elements are inserted, then I delete 5 elements, it will become empty. After it has become empty, the space can't be reused again since the front and rear would have gone above if you have not handled it properly. That is, after reaching the maximum size, again the rear and front end should be reset to -1. If you have not done the resetting, that particular space will not be reused. So that's the problem. So that problem can be solved using circular queue. So what are the limitations that are there in the queue which will be normalized using a circular queue? So it follows the same property first come first serve, that is FI FO, but it is called as ring buffer. Why it is called ring buffer is it checks again whether there is a space in the queue. If let us assume I have 5 elements, in 5 elements I have inserted 5 elements, then I have performed 2 elements deletion. When you try to insert again, even though there are 2 spaces above, the rear end will be assigned to -1. Since it is not in circular fashion, it will goes in only one directional way. So that is the major difference with the ordinary queue and circular queue. That's why the circular queue had a ring buffer option. So I have given an example. You can see here the below example is given with what is the operation. So you know what is NQ, DQ, what are the operations that are performed on the queue is same way they performed it on circular queue also. So we have NQ, DQ, display. One more function will be there is to check whether it is empty or it is full. So that you can have it in the NQ and DQ operation itself. We will see that. Again, you will be having 2 pointers here, front and rear. Front will refer the first element of the queue and rear will be referring the last element inserted in the queue. So this is how the operation. Now you can see an example. We have an example. So it's a circular queue of size 6. Okay. So you can store 6 elements in the queue. Now I am performing NQ operation for 6 elements, that is 5, 10, 15, 20, 25 and 30. So 6 elements have been inserted. After that I performed 2 DQ operation. So if for the first 5 went, the 0th position front will be there and rear will be in 5th position with all the elements 5, 10, 20, 5, 10, 15, 20, 25, 30. When I perform DQ operation, front will get decremented. Now 5 will be deleted, 10 will be deleted. Now front will go to the 2nd position. That means 2 elements are deleted, front will be in the 3rd position. Now again I insert 35 and 45. How? Because 0th position and 1st position are empty. So rear will be getting updated. So it is in the form of circular format. So we'll see in more detail in the upcoming topics, upcoming slide. So why do we have to go for circular queue? It is mainly used in operating systems. So it is mainly used for two types of management. One is memory management and another one is the process scheduling. So circular queues are more widely used in for scheduling algorithms. Sometimes it is also used in traffic systems. Okay. This circular queue is implemented in 2 ways. One is using array implementation and another one is using linked list implementation. So we'll be seeing in this topic, we are going to see how array implementation is used for implementing circular queue. Similar to queue, so which is implemented by array. So I'm going to use CQ as an array, which is of size 5. So you will have a circular queue with the size 5 here. And I'm going to have 2 variables, front and rear, which are assigned -1. So initially my circular queue is empty. So both front and rear will be -1. If my circular queue is empty, front and rear should be -1. Same way, insertion in a circular queue will be checking only 2 conditions, whether my queue is full or not. If my queue is full, enqueue operation fails. If the queue is not full, then you will perform your insertion. So how do you insert it? If it is the first node, front and rear will be updated. If it is having more than one element in the queue, then rear alone will be getting updated. So that's the three parts we have in insertion in a queue. So first part, you will check whether my queue is full or not. Second part, whether it is the first node or first element of the queue. If it is not the first element, only rear pointer will be updated. So initially, if the queue is empty, you can see I have shown a diagram with a circular queue of size 6. So it doesn't mean that circular queue means it should be in a circle format or spherical format. It is not like that. It will be like an ordinary array only. The only thing is the front and rear will be handled in such a way in a circular fashion. Okay. So I have 6 position. Initially both front and rear are -1 and all the 6 locations are empty. Now in circular queue, when insertion fails, when my queue is full, insertion fails. So let us have a simple example. That is, I have queue is empty. I have inserted 6 elements 35, 40, 15, 20, 25, 30. That means front will be in the first node. What is the first node? 35. The last node is 30 because it is inserted at the last. So you can see front and rear. When I try to insert again, what happens? The queue is full, there is no empty space. Now how do you check in your coding? So the first condition you will be checking here is if the front is equal to 0 and rear is equal to max -1. That is, if my size is 6, it should be 5. If front is in 0 and rear is in 5, then my queue is full. So this is an example that if insertion is done in without any deletion, how to check my queue is full. If front is equal to 0 and rear is equal to max -1, then my queue is full. There is another possibility that queue can be full. Suppose I have performed some insertion, then I have performed some deletion, again I have inserted some elements. In that case also, the front and rear will getting updated. That means after insertion, again deletion, front will be moved to some other position. When I try to insert, rear is in the last node, again there are free spaces, so it starts again from 0, 1 and 2 and it is getting updated. Now if that is the case, you will have another condition to check whether my queue is full. How? If front is equal to rear plus 1, that means front above front, if there is rear, that means my queue is full. So how this operation can be happen? Because it's a circular queue, the spaces which are deleted can be reused again. In such a case, if the spaces have been reused, the front and rear can come above. It will not cross each other, because if it is crossing, there will be a overwriting. So if they are nearby, rear first and then front means my queue is full. So we'll see how this happens in our insertion and deletion. I'll show you an example in upcoming slides. Now let us start. I am inserting, my queue is empty. I am going to insert the first element. So how do I check my queue is empty or not? That is initial condition, because it is not being used. It's fresh. It's totally empty. So you will see the coding. If front is equal to -1, that means my queue has been untouched. So what I do is I just assign my front and rear to the first position, that is 0th position. So front is equal to 0, rear is equal to 0. So front and rear are assigned to the first node. In the array means, so array of rear is equal to the item. So here item or x, which will be the same. So I am just inserted the new element in the rear end. So 35 is inserted in the rear end. There is one and only element in the queue. So this is how the circular queue for done, which is similar to ordinary queue. Now after inserting the first element, I am performing another 4 enqueue operation. That is, I am trying to perform another 4 insertion into the queue. Now which code will execute? Now if you enter into the code, first condition fails because it is not full. The second condition, front is equal to -1, no, the queue is already filled up. So what happens is, it will just come to the else part, rear is equal to rear plus 1. So what happens is the rear is not equal to max 1 because it has not reached the last position. So your rear is in the 0 only. So what happens? 0 plus 1, the first position will be given for 40 and second position will be given for 15 and third position will be given for 20 and fourth position will be given for 25. So what happens? So 35, 40, 15, 20, 25. So only rear is getting updated, front still stands in the 0th position. So the total size is 6. So I have inserted the last element as a 30. Now you can see my queue is full. How do you say that? My rear is standing in max minus 1. Max is 6. So it is going to be 5 and front is in 0. From the queue itself we can see it is fully occupied. So this is the example. Until then this code. Now we will have a question. So when this rear is equal to max minus 1 condition will be checked. So you will see in the next example. So in the previous slide, all the elements have been occupied. Now what I am going to do here is, I am going to delete 3 elements. So I have performed 3 DQ operation with the circular queue. So what will be the first element coming out? It will be 35. Then second element will be 45. Then 15. So if these 3 elements have been deleted, what happens? Front will be getting updated. So when 35 is deleted, front will come to first position. When 45 is deleted, front will come to the second position. When 15 is deleted, front will come to third position. So now front is in 20. Okay. So you have only 3 elements in the queue. Now I am going to perform insertion and queue operation. I am going to perform another 1 or 2 elements. So let us assume I am going to insert the first element. Now first, we will check the condition. Rear front is equal to 0, rear is equal to max minus 1. But rear is equal to max minus 1, but front is not equal to 0. So the first condition of if case fails. Again, the second condition, front is equal to rear plus 1. No, that condition also fails because rear plus 1 means it will be in 6 and front will be in third position. So both the condition for Q full fails. Right, we'll come for the next condition. Front is equal to minus 1. No, the front is in third position. So this is not the first element. So we'll come to the else part. Now here, if rear is equal to max minus 1, that means rear has reached the last position of the array. Yes, it has reached the last position. There are spaces available. Yes, because space is available only, we have come to the else part. So there are some spaces available. So what I do is, I am just assigning rear is equal to 0. So what happens? From 5th position, rear goes to 0. Now the array new item will be stored in 0th position. So 4 is stored in 0th position. So this is the fashion of circular queue. Even if the rear pointer has reached the last position, if the spaces are available at the top of the queue, that space can be reused. How do I assign the rear pointer to the first position of the queue? So in this fashion, the circular queue works. So after inserting 4, what happens if I try to do another insertion? Again, rear alone will get updated. So here we'll check only the condition is whether it is full or not. The first condition say it is not full, and again it is not the first element or freshly the queue is not empty. So queue is not empty, but the space is there. So you just need to update the rear pointer alone. So what I do, rear is equal to rear plus 1, and in the rear pointer I will just store the element new element. So rear comes to first position and the next element 5 is inserted in the first position. So this is how the insertion happens in circular queue. So the next is DQ. So when DQ fails, when queue is empty, DQ fails. If the queue is not empty, we will delete the elements. Now in this DQ, if the queue is not empty means whether it has one element or more than one element. If it is more than one element, update the front pointer. If it is having only one element, delete the front node and make front and rear null. Okay. Now if there is more than one element means I have to delete from the front node. Suppose front has reached the last node and still elements are there. What you will do? It's a circular fashion. Again the front has to come to the first position because front has come to the last position. After deleting the last position, again front has to go to where? If the queue is not empty, it has to come to the first position. So we'll see an example for that. Let us see the example if the queue is empty. If queue was empty, front will be always -1. So if front is equal to -1, you can simply print my queue is empty. If queue is not empty, that means there are some elements available in the queue. So I have to delete the elements. So where do I delete it? From the front end. So where front pointer is referring, that node should be deleted first. So you'll simply print the CQ of front. That means that is the element that is going to be deleted, and front will be equal to front plus 1. So all other conditions will not be checked because front is in 0th position and rear is in the 5th position. So if you delete 40, 15, 20, 25, 30, front will be moving from 0th position to 5th position. It moves in forward direction. The same example, now you can see how 40 is deleted. If 40 is deleted, my queue is not empty and both front and rear are not equal. If they are equal, it is empty. So I have to make it empty because there is only one and only element in the queue. So we can see an example for that. Now 40 is deleted, front is going to the second position, so 40 will be deleted and front alone will be getting updated for deletion. Now this is an example. After deleting all the 5 elements, you can see there is only one element in the queue. Both front and rear will be standing in the same node. Now in this thing, again, I'll print the element where front is standing. So CQ of front, that element is going to be deleted, so it will print that T is deleted. Now in this condition, you can see there is only one element. If there is one and only element, front and rear will be in same position. If after deleting that one element, my queue will become empty. So what I have to do, I should not assign front and rear to 0. I should make it as -1 so that to reuse it again. So what happens here? Front and rear will become -1 after deleting 30. Now this is another example. From the left side diagram, what you can see? You can see here front is in the 5th position and rear is in the 2nd position. Can you tell or guess what has happened here? So I have inserted 6 elements, then I have deleted 5 elements, then again I inserted 3 elements. So if that happened, this is how the front and rear will be. So when I inserted 6 elements, rear will be in the 5th position, front will be in 0th position. When I deleted 5 elements, when 0, 1, 2, 3 and 4, all the positions have been deleted, front will go to the last position. After deleting 5 elements, if I insert again 3 elements, rear will go to 0th position, 1st position and 2nd position. So 35, 40 and 50 have been inserted at the last. So this is another case. Now in this case, if we are after again trying to perform a dequeue operation, what happens? Now front is in the last position. After deleting 30, still elements are there in the queue. What is the next element to be deleted is? That is going to be 35. So it's a circular fashion. After deleting 30, the front has to come to 35. So how it has been done? I simply print CQ of front. So it will print 30 is deleted. Now I will check the condition if front is equal to rear. My front and rear are not equal. Okay, because since my queue is having more than one element. So it comes to the third part. Now here I check if front is equal to max -1. Yes, my front is standing in the last position. So what I have to do, still my queue is not empty. More than one elements are there. So from last position, I have to go to the first position to read the next element. So I have assigned front is equal to 0. So after deleting 30, you can see front has come to 35 and rear will be untouched. So the next one is display. Only 2 conditions. If my queue is empty, display fails. If my queue is not empty, I have to print all the elements of the queue. So let us see how to print all the elements of circular queue. So we'll take an example. Now my queue is full, no deletion is performed. All 6 elements have been inserted for the first time. That means front will be in 0, rear will be in the last position. Now I'll just check for the condition whether front is equal to -1. If it is equal to -1, it just prints my circular queue is empty. Now if this condition fails, we will come to the next printing mechanism. I'll check for the next condition whether front is less than or equal to rear. That means if front is in first position and rear is in the last position, front will be smaller than rear. If that is the case, print all the elements from front to rear. So how did I do it? I used a for loop. For int f is equal to front, f is less than or equal to rear, f plus plus. Print all cq of f. So in this queue, it will print from 0th position till 5th position. So it will start printing 35, 40, 15, 20, 25, 30. So this is a simple example without any deletion. Suppose there is some insertion, deletion, and again an insertion might have happened. Multiple insertion and deletions have been performed. That means rear and front have been nearby. What will be the case? So if that is the case, what you are going to do here? So first my queue is not empty. Again, front is less than rear. Now if you see, if after some deletion, rear might have reused the space. In that case, rear will be less than the front. Front will not be less than rear. Okay. In previous case, rear was bigger than front. Now in this case, front is bigger than rear. That means from front end till the last position I have to print. After that, I have to start reading from the first position onwards. Up to which? Up to rear. So I have used two for loop here. The first for loop from the current front position till the last position. So f is equal to front, f is less than or equal to max minus 1, f plus plus. Now it will print all the elements from 3rd position to 5th position, that is 20, 25, 30. After printing this, the reused space also has to be printed. Now f is assigned to 0. So starting from the first position onwards till rear position I have to print. So f is equal to 0, f is less than or equal to rear, f plus plus. I will start printing the 0th position and first position. So now according to this, what is the first element? 20 is the first element. What is the last element? 5 is the last element. It will print 20, 25, 30, 4, 5. So that's all about circular queue, which is implemented using array implementation. Thank you.